Hey, Wire Monkeys, welcome to another episode of Let's Talk Cabling. This episode, we're talking about Ethernet and bananas. What's the correlation? Welcome to the show where we tackle the tough questions submitted by installers, estimators, project managers, customers. We're connecting at the human level so that we can connect the world. If you're watching this show on YouTube, would you mind hitting the subscribe button and that bell button to be notified when new content is being produced? If you're listening to us on one of the audio podcast platforms, would you mind leaving us a 5-star rating? And if it's not a 5-star rated show, let me know what I can do to make this a 5-star rated show. Those simple little steps helps us take on the algorithms, helps us educate, encourage, and enrich the lives of people in the ICT industry. Thursday nights, 6 p.m. Eastern Standard Time. What are you doing? You know I do a live stream on TikTok and Facebook and LinkedIn and a bunch of other places. But I can hear you now. But Chuck, I'm driving my truck at 6 p.m. I don't want to get in the car. I'll crash. I gotcha. I record them and they're put on the website so you can watch them at your convenience. Actually, I came across the guy at the Bixie conference that says he watches them on Fridays because he listens to my advice. Because you know I am your favorite RCDD. Also, even while the show is free and will always remain free, if you would like to be a supporter of the show, would you click on that QR code right there? You can buy me a cup of coffee. You can even schedule a 15-minute one-on-one call with me, after hours, of course. And of course, we're always looking for corporate sponsorships. So as long as you don't mind being on an agnostic platform that talks about everybody, and your company's values are educate, encourage, and enrich, hit me up on one of the social media platforms. Let's talk about it. So I recently saw a really cool video. I don't know why it popped up in my video feed. Well, it's funny. I watch more YouTube videos than I watch TV, and it popped up and immediately caught my attention because my good friend Mike Pennacchi was on. I was like, "What? Mike's on the video!" So, and then I stopped, and they start talking about putting Ethernet through bananas. Yes, you heard me right, through bananas. And to me, this solves a huge debate that I hear all the time in our industry, because you hear people say, "Well, you can't do 10 gig on Cat 6." Yeah, you can. You just can't do it out to the full 295 feet. There's a difference between the cable test limits and the IEEE test limits, and a lot of people don't understand those. I don't even know if I thoroughly understand those differences, but I know somebody who does. So I reached out to Mike and I said, "Mike, great video. Can I get you on the show?" And he graciously said, "Yes." So welcome to the show, Mike Pennacchi. How you doing, my friend?
Fantastic. Good to be here, Chuck.
Glad to have you back. It's been too long. I think it's been over a year since you've been on last time.
It has. Yeah, we need to get together more often.
We do, because I love having guests on that the chemistry's already there, right? And you already have a video presence, so you understand, not to have the weird things going on behind you and stuff like that. I won't even mention, but I did an interview with sometime. I said, "You might want to take that thing off the shelf for this video." I'm like, "Oh yeah, I guess I should." Yeah. It's not appropriate. So it's good having somebody on the show who understands those things. And like I said, and you and I, we run a lot of the same circles, and we have a lot of very similar backgrounds. So it's like talking to an old friend. So first off, what was that event that you did that video that you guys did that event at?
So last week I was at the Wireless LAN Professionals Conference in Phoenix, Arizona. And I was there part of it was to do some training for NetAlly on their CyberScope Air, which is their new network analysis and cyber tool that they're coming out with. And they're going to be announcing that pretty soon. But we kind of did an early release on it and did 6 hours of training on that. And then we had a couple of other things. We had an evening event. And when we were getting ready for this conference, we met with Keith Parsons and Fernay, who were the two of the people that put the conference together. They were saying, one of the things, we spend a lot of time talking about wireless, but you can't run the access point if you don't have a wire running to it. So we were talking about different problems they had run into and things like that. In fact, It brought up on LinkedIn. I posted a picture. I put 295 feet of Cat 6 in my oven. And I was in there, I was punching the buttons, and my wife could hear me. And she goes, what are you cooking? Because I don't bake anything. And I said Cat 6. And she goes, oh, okay. Because she's used to that kind of stuff going on around here. And what I wanted to see was Fernay had brought up that he was troubleshooting a problem where they had intermittent connectivity during the day. So they would go in and troubleshoot it in the evening when they had access, and there were no problems. Well, in the end, what it turned out to be was the cable had been zip tied to a hot water pipe.
Oh,
And so during the day, hot water was running through the pipe and it was heating that cable up. So I was curious, what impact does heating that cable up? So I was able to get it up to 135 degrees before it started gassing off, fumes. And that's the other agreement I have is I can't stink up the house if I'm going to run tests like that. So I threw the DSX cable analyzer on there and I ran a test, and we could see that when the cable was at 72 degrees before I put it in, it passed insertion loss. But when we got that up to 135 degrees, insertion loss failed with about 1.5 dB of we were 1.5 dB below the limit line. And we see that sometimes people end up, like down there in Phoenix and some of the Southwest states, installing cable in buildings that isn't air conditioned yet.
Right.
And that can actually create a problem that you've done an adequate job installing the cable. But because that cable, when it's rated, is rated at 68 degrees, we find that, if we exceed that temperature, that derates the cable.
Yes, it does.
And another one that I talked about there was thin patch cords. People had thin patch cords all over the place. And we find out that those derate at a rate of 1.95 per meter. So we're losing, for every meter of those that we put in, we're really losing a couple meters of overall length. And so we have to be careful with our permanent link and how long that is if we're putting thin patch cables on each end.
Yeah, that's an absolutely great video. I'm gonna put the link for it down in the description, so those people who are actually listening to this podcast, not watching it on YouTube, I highly suggest you go to the YouTube and watch the video because we're gonna do some fun stuff on this episode. But I'll put the link down below to that video. And I remember you telling that story when you're speaking to that event, and when you're talking, it reminded me that I got banned from using the oven because I used to put my car parts in it to oven bake the paint on the car parts. And the only reason I'm allowed to use the oven now is because I divorced that wife. My new wife doesn't know about my past history in car parts. But see, and here's the funny thing. This is why I love talking with you, because I go to the Big C events and the NECA events, and I talk to people all the time. And it's funny because you can talk to people in this industry, and you can tell when somebody's passionate about this industry, like you or I, right? And I was telling somebody at the Big C Winter Conference, and I said something about I took a 100-foot piece of cable, I terminated it A. I tested it because somebody said A performs better than B. And I've always been told it doesn't. And I was like, you know what? I don't really know that. So I took a piece of cable, I terminated it. A, I tested it, cut the ends off, terminated it. B, tested it again. Now, the parameters were nearly identical. I mean, there was a tiny bit of difference, but I couldn't attribute that to maybe the difference in termination skills between the A and the B. Maybe the one was a little better than but it was what they were so close together. It was a null issue. And I explained it to somebody, and they looked at me and they go, man, when I get off at 5 o'clock, I don't even think about cabling. I'm like, well, there you go.
What?
Right.
I think about it all the time.
Right? I mean, ask any technician when they're walking through a store, do you look up at the ceiling to see where the WAPs are or where how the cabling's done? Because I'm telling you, technicians do that on a daily basis. We forgot to do the introduction. We forgot to tell you everybody who you are. So give us the introduction.
All right. So I'm Mike Pennacchi. I own a company in Seattle called Network Protocol Specialists. And for the last 22 years, I've been going out and troubleshooting network problems, a lot of packet capture analysis, things like that. And about 12 years ago, I've been working with Fluke since the late 90s. And Fluke Networks came to me and said, hey, do you want to run our certified cabling test technician training program? I said, sure. So I've been doing that for the last 12 years. And just before the pandemic, we had started looking at how could we set it up so that we could offer the class remotely. So I had a few weeks where I had some wisdom teeth pulled out. I had some time because, there's never time to really focus on things.
Right.
And I figured out, I found some software called Guacamole that allows me, here we're talking about guacamole and bananas and things like that today, but it allows me to go from an HTML browser to VNC, which allows me to control the versives. So what we do is we've got it set up so when we're doing the classes, everybody remotes into a versive here. So that way they can actually click on the tester, go through all the exercises. I can see what they're doing. So that way, if they get stuck or something like that, I can go over and help them out. So it's worked out really well. So I spend, these days, I spend the majority of my time on the physical layer and working on those problems, but I still get called in and asked to troubleshoot things. So I work with Fluke Networks, I work with NetAlly, I work with a company called Profitap, and I've found some nice non-overlapping companies that provide complementary tools. And my goal, educate, right? And be an evangelist for this technology. I know it's not fun for everyone, but at least let's make it interesting. And that's where that presentation came out. We were doing the evening event, and Dan Klimke at NetAlly, and I'll make sure to give Dan credit for this one. Dan said, hey, we need to do something fun. I had slides on cable lengths and
death by PowerPoint.
IEEE.
No.
And it's like, I really don't want to do that. And he said, I hear you can run Ethernet through bananas. So he went down to the cafe and he picked up 4 bananas, and I had some Cat 6A. And that piece of Cat 6A, what I showed was where it was terminated where we didn't have any strain relief. We had the little ice cube crimp on connector, but the jacket didn't go all the way in there. And I'd been out for pizza a few weeks before, and I'd seen where they'd wired up these cameras, and there must have been an inch back, of insulation strip back before the connector. And one of the things that we see with that is that those little vampire tap fingers that go into the cable aren't designed to hold it in place. So as that connector gets moved around, we start seeing a resistance unbalance. And when we run in PoE, if more current is flowing over one conductor than the other, that throws the transformer off that's in the transmitter, and we can see data loss. So if you don't ensure that you have the proper strain relief on the end of those connectors, then we start running into some serious problems. And so
it's not just an aesthetic thing that you got to make sure that you got to do it nice and pretty and have the insulation run all the way up.
No, it's not. In fact,
another one I hear all the time. I promise we'll get back on subject here in a second. Future episode, we need to get you on to talk about that online Fluke training. But
okay.
So one of the things I hear all the time is people say, A versus B, it doesn't matter as long as it's the same color on both ends. To an extent, right? As long as it's A on both sides or B on both sides, okay. But you can't just put white, blue, blue, white, white, orange, orange, white, white, green, green, white, because you're splitting pairs, and it's not going to work.
In fact, let me go back here to the drawer. So one of the things I did a little online conference about 1.5 years ago, and I wanted to show people. I bought one of these little. It's a $29 power meter I got on Amazon. Now, not only does it do optical power, but it came with this little dongle so that I could do a wire map. And we'll see if we have time today. But one of the things that I showed was that the wire mapper, when you wire a cable incorrectly, just like you brought up, this shows it's okay.
Right.
And I was talking to a friend of mine that does a webcast as well. And he was, he had some cable installed, and I said, how are they testing that for you?
Right.
And he said, they have like a little wire mapper. And I said, let me show you something. And
we got to do it. No. We got, even if I have to break this up into 2 episodes,
we'll wait
we
for that one.
We got to
We'll
do it
do that one.
because I'll tell you why. I mean, literally, right before this recording, I was on about an hour ago. I hopped on a live stream, and there was a couple guys talking, and one of the guys says that he only brings out the certifier when the customer's paying for it, that they use wire map tests. And I just said, wire map tests don't give you the whole picture, right?
No.
And then he says, yeah, no, I get that, but it works fine for us. And I didn't really, you know what? I was doing 4 other things at the same time. Like you, I multitask. I'm like, I'm not going to get in this argument with this person because I will see him literally in a couple months. I'll talk to him face to face. So yes, we're going to do that now because I want you to, like I said, you can have issues like you can have crosstalk issues, EMI issues, all that a wire map test is not going to show you. It'll show fine,
No.
but it won't show that.
I bought a box of CCA. It says Cat 6 on it.
Yep.
Right. But wire mapper, hey, it looks great. Right. So we have split pairs. We have, and really, how many times, I mean, as long as you're getting your pairs down right and you're punching it down, you're going to have continuity.
Right.
But we'll talk about POE
Yes.
and why resistance balance within a pair and between pairs is so critical when we go in and do that.
Yes.
And I've got some class 8 POE stuff we can set up. And we can actually see that as we increase the power draw, we start seeing data loss.
Yep.
So
now before you start doing the demonstrations, can you talk just briefly about the whole root of this issue is we have the TIA testing limits and then the IEEE parameters, and sometimes they don't match, and that's why I think it causes a lot of these arguments. So can you just kind of touch on that a little bit first?
Let's go one step even further, and that is we have the TIA limits, and those are our cabling limits. Right. So if I test a Cat 6, Cat 6A, if I'm testing ISO, I'm doing class E, class EA, which there are times when we're selecting limits, it's important to understand how those correlate.
Right.
Because there are some limits that are not in TIA. And so if we have to go over to ISO, we have to know that Cat 6 is class E.
Right.
Right. And that they're a lot of the same values. But so we have those, and those are our cable limits. And I've got a 94 Suburban with a tandem axle dump trailer. And so I always say that, if we do a cable test, that's like saying this bridge is rated for 20 tons. So I know that I can drive my truck and my trailer over it, and it's going to be just fine. Now, IEEE has limits for the application. And so the application is 10 base T, gig, 10 G base T, 2.5 G base T. Now, in many cases, these require much less than what's required by the cabling limit. So just because a cable doesn't pass Cat 6 doesn't mean that it won't pass gig. In fact, I've had a few cases. I had one former student call and say, Mike, look, we're out on a job. We didn't install the cable. We're testing it. There are 500 cables. Because of the security at this facility, once they pulled it, they poured concrete over the pull boxes. So we're not ever pulling this cable out. And we've got 6 cables that won't pass Cat 6. The customer wants to know, will they do gig? So what we were able to do is within Linkware PC that works in conjunction with the Fluke certifier, we could recertify that cable. And what you'll see is anytime you generate a report out of Linkware Live or Linkware PC, down at the bottom, it says compliant network application.
Yes.
And so what happens, the software takes and compares the limits for each one of those applications to the measurement, and it says this meets that. So now you can see every IEEE compliant application that will run across that cable. And so sometimes, depending on the situation, we may not have a cable past Cat 6, but we could still certify it to gig or 2.5 or 5 and say that's going to work. So it's very important to understand that difference between the TIA limit and that application limit. Now, one of the things we're going to look at today is I've got the NetAlly EtherScope NXG and LinkRunner 10 gig. And they've got a program in there called LANBERT. And what LANBERT does is it actually sends the traffic. So there's times where we say, okay, it didn't pass any of these, but will it work?
Mm-hmm.
And that is like driving the Suburban and the trailer across the bridge to see if it collapses.
With a tractor and the dump trailer, because now you added extra weight.
Oh, yeah. Well, I've got my new toy. I bought one of these Chinese mini excavators.
Oh, cool.
Yeah. So that's been kind of fun to play with. Do I really need it? Probably not. But boy, it's fun for digging ditches around the property. So in this case, what we're doing is we're actually sending traffic. And what we find is that the digital signal processing that occurs on the network interface cards overcomes a lot of issues out there. So we may have a cable, or in this case, some bananas over here that we would never expect. We could put a qualifier. And before we jump into the demonstration, let me just mention, oftentimes we see with the qualification tools like the Link IQ from Fluke, these apply the application limits. So they will tell you 10 gig or 10 base T, 100 base, 2.5. So what they're doing is they're applying those application limits to say, they're not certifying the cable to the cable limit. They're saying, will this application run across there? So it would be interesting to run it through here. Now, for the demo that we did, Dan Klimke at NetAlly said, hey, I heard, somebody ran Ethernet through bananas. So I had a piece of Cat6A. He cut it in half. He cut 2 of the pairs because we had 4 bananas. So in the video that we put that's out there on YouTube, we did 4 bananas. So for you, I really wanted to bump it up.
Nice.
So I went and I found a hand of bananas at the store yesterday that had 8 bananas. So I've wired up all the conductors. And in fact, we've got our white orange over here.
Uh-huh.
We've got our white green. We've got our blue. So
you got 568 bananas.
568B.
Right.
Right. We had to use B. Now, the other thing I'll point out before we do our testing is I was able to get 100 meg, and I don't know how it'll show up in the video, but I thought, you know what, too much crosstalk between the bananas. So I got some foil and I foiled every other banana. So we have some shielding in there between the bananas. So what we're going to do is I'm going to come in and I am going to share my screen here. We'll grab the entire screen. We'll hit share. So this is the 2 testers I have sitting here on the bench. And this is a link. Oh, let me switch back to me. This is a LinkRunner 10 gig, and this is an EtherScope NXG. And I forced these to 1 gig. And so what we're going to do is I'm going to come in here and I'm going to hit start on the generator. And we'll see if we can get this to link up. All right, so our test is running. And we're seeing about 6.4% packet loss, which really isn't bad through 8 bananas. Now, when we did 4 bananas, we were able to get 5G base T with 0 packet loss. But adding those extra bananas in there kind of throws us off a little bit. And what I found, I had to reposition the cables this morning because I found that as time goes by, that loss value starts going up.
Yes.
And so eventually I was able to run it last night for about an hour and a half. So we are getting Ethernet through there. And so part of why we showed this was we wanted to be able to show that even though a cable doesn't meet any of those standards, the devices on each end may be able to compensate. So ideally, what we want to do is we want to certify. We want to say that this cable meets the standards for that cable. And if we can't do that, we may want to qualify. And if we can't do that, then going in and testing and making sure that we're getting that traffic through is really important. So what I'm going to do is, I'm going to take and set the bananas off to the side. We're going to change our test just a little bit here. And I used Cat 6A because I wanted to give myself the best chance of passing this thing.
There you go. Try to pad the test results a little bit there. Use the best.
Exactly. And I got to make sure I put that tray back, because that tray isn't designed to be out here for experiments, right? Now we will switch over. Let me switch over here. Here's the two testers I have. Now, one of the things I wanted to show you, I'm going to come over here and grab a couple of patch cords, and that is, there was a question about flat patch cords and how do these perform. So I have a whole pile of stuff that's going off to the recycler. And before I got rid of it, I thought I better grab some of these patch cords. And they're marked as Cat 5e patch cords. So what I'm going to do is I'm going to switch over here. And I've got this patch panel right here that goes to a huge box of cable. So this way I can wire up all the stuff that I want. And we'll swing over there, and I've got here, this is 295 feet of Cat 6A cable. So I'm going to plug those patch cords in there, and then I'm going to connect those patch cords to the two testers. So we'll come in here, we'll switch over there, we'll get those testers lined up right there. I'm going to share my screen again. And what I want to show you is if we go in and we run a test on that, and this time I expect that with that cable and everything, I could get at least 5 gig out of it. So I'm going to come in here. I'm going to set that to 5G base T. I'm going to stop this end. I'm going to set that to 5G base T. I'll start my remote, and I'm going to start this end. So now, I'm going to link up. Well, we may not be able to get 5 gig out of that. So let's go with 2.5. So we'll set that to 2.5. We'll stop there. We'll set this to 2.5. And what's interesting is that is the impact that these Cat 5e patch cords have on it, is that is a Cat 6a link. I should be able to get 10 gig out of that. So I'm going to go ahead and hit start, and I'm going to hit start.
Yeah, but the cable's Cat 6a, but you're using 5e patch cords. So
yeah,
you should, well, 5e can do it can easily do a gig, a shorter distance, shorter distances.
Exactly. All right. Well, this is fighting me today. We're going to do 1 gig. Of course, because we're recording. But that's the fun of these types of things.
Yep.
Is finding out what works. So we're going to come back. We're going to hit start. Maybe this thing is so used to working with bananas that, all right. So now we're sending traffic through, but we're seeing, we're getting a few errors on there, right? Now, what is interesting is, look what happens when I start bending those patch cords. We see our errors jump way up.
Yeah, you do.
And so this is the other part, is that sometimes when we're doing testing, if we're doing either qualification or certification, we're taking a snapshot in time, right, number one. And unless we're doing a channel test, we're taking a snapshot of the permanent link. And I watched your presentation on MPTL, which one of the things I really liked was where patch cords come in. And patch cords, the comment I heard was disposable, that these are a consumable piece.
Right.
And so they're designed to be moved around. We want patch cords that can be moved. So if someone moves their computer or something like that, we don't run into problems. the thing is that if we just take a snapshot in time, we don't see some of these things. And so if we come back over here and watch our errors, so our errors are going up slowly on there, but as soon as I come in and start flexing these patch cords,
Yeah.
we start running into issues. Now, what I would expect, I'm going to hit stop on there, and I'll grab a couple of really good patch cords. These are a couple that one of my clients in downtown Seattle here actually had their electrical contractor certify their patch cords properly by using patch cord adapters.
Right.
And these were the patch cords that are manufactured by a local company here that they came up with. And so let's just see how, and check, just looking at the patch cord, we're going to replace, all we're doing is replacing the patch cords. I didn't change the link that they're connected to. So we're going to plug those patch cords in. And what I'm going to do is I'm going to stop this side. We're going to go ahead and set our speed to auto.
So that way it'll determine the fastest speed it can do between them?
Exactly. So we'll go back. We'll hit start. We'll hit start right here. All right. So we just linked up at 10 gig full duplex.
Nice.
And we're seeing 0 errors. So we're operating at 10 times the speed, and we don't have any errors. And if I take these patch cords and I massage those around, we're operating at 10 gig now. We don't see any problems. So when we're looking at our link, not only is it important that we take a look at how that permanent link is performing, but the link as a whole. And I didn't even plan this one out for today, but the fact that just changing out those patch cords took us from 1 gig with some errors to 10 gig with no errors, we can move those cables around.
Well, so you proved 2 perfect points here, right? Because I think at the tail end of that MPTL video, I think I said that the 3 most important things are going to be the quality of the material, right? The quality of the installation, and those 2 overlap, right? I don't remember what the third one was off the top of my head. And so, like I said, the TIA testing limits is set up so that those networks or those devices will communicate 99 and 44 100ths. If you know where that comes from, put it down in the chat box, right? All the time. That way you don't have headaches, right? But if you run that cable and that cable's laying across, the red iron every, 5 feet in a big bundle, and it's on the bottom, it's getting crushed, even though it's under the permanent link length of 90 meters, 295, it's going to cause it problems. So it's not just the quality, because you proved the quality of the patch cord there, and then when you started massaging it, that kind of showed the quality of the installation. So that's what I say all the time. It's 2 things. It's those 2 things that really are going to guarantee your success in your installs.
Well, and that's why we see that I've made my fingers, I can't even feel the tips of my fingers anymore after all the cables I've crimped together and stuff. But any chance I have now, I use field terminated plugs on the end of the cables, because I've got those insulation displacement connections. It's got a printed circuit board. It's going to give me better return loss and near end crosstalk performance. And I'm going to get a more reliable crimp. And I'd always kind of been in the middle on pass through. In fact, the banana cables, I use some pass-throughs. But I've got a pass-through cable that when I plug it into the channel adapter, or actually the patch cord adapter on the DSX, it's showing a short. And that's something that I've seen people complain about.
Yes.
And I've always felt that if you use the right tools to terminate those, you're less likely to run into that problem. But having those copper ends exposed there offers an opportunity. So I'm still a little bit on the fence. They're an easy way to terminate, especially the Cat 6A cable, where you're getting that load bar in there and everything.
That
Um,
that's a huge debate in our industry right now. I mean, go to any one of the social media groups,
oh,
and every other post is people arguing pass through versus traditional modular plugs, and I'm kind of with you. I've seen enough pictures of pass through connectors where they've arced out or water's gotten into them or whatever the case may be to make me say, you know what, even though I can do pass through, yeah, I understand they're easier, I'm going to stick with the traditionals. But the best is going to be, and Dan and I talked about that in that last episode, is the one made at the manufacturer, because they use better
yes.
quality crimpers. They maintain their crimpers, and a lot of people don't know this. Those dies have to be replaced. They're consumables.
Oh,
They are consumables. You know,
I totally, I mean, making those cables last night, I totally destroyed an ice cube connector with my crimp tool. And it was just a little bit off for that particular connector. And it put a big divot. In
yep,
fact, maybe in another one, I'll grab my USB microscope and we'll take a look. But it just destroyed that connector. And so you got to have the right dies, as you guys mentioned,
right,
the dies wear out. I was having trouble getting some to crimp one time and I kept ratcheting that thing down. I was going the wrong direction. It was pushing the pins too far in.
yep.
And, we can have a bad combination of a RJ45 and a switch or something that the pins are up a little bit higher and you're pushing the other ones down too far and it just doesn't work together.
Yeah, quality tools and maintain them. That was the third thing, was tools. My mind just totally
Oh,
went blank on me. But hey, when you get my age, stuff like that happens sometimes, right?
and I think whether it's hand tools. I mean, I remember I had
Right,
the 40-piece socket set from Kmart. It was like $5, which was not a bad thing to have in the car. Down there with the spare tire,
right.
something goes wrong, you got to. But those things would just rip in half. And I've learned. I've had the fortune to work with manufacturers over the years where I've had an opportunity to use some of the best tools in the market, and it's given me and you go out and you talk to people and they say, well, I wish I had the money to do that. Well, if how many times do we have to go back and retest?
Right.
How many times do we have to lose out on a contract or something when you don't have the right
And
tools?
and,
And
and you can't. People can't tell me how to calculate this. Maybe you might know and I don't. How do you calculate how much money you lose because of loss of customer confidence because your tool wasn't done right or wasn't maintained? Let me know if you know the secret formula of that. Let me know.
well, and it's like so many things, you'll never hear it
Right.
because they'll never tell
Yeah,
you.
and they'll quit using you.
But what
They'll
will
quit.
happen is they won't come back.
Exactly. Exactly.
And so yeah, I started buying the pack out cases, and even I'm not going out and doing installations and so on. There you go. In fact, one of the things that I was looking at is, uh, you know, taking and getting some liners made for that the Fluke Versives fit in,
Right.
so you could put those right into a
Yes.
pack out.
Yes.
But
Yes.
having the right tools, and whether that's test reference cords or cables, another one we see people do all the time is their permanent link adapters on their testers start failing.
Yes.
So they switch over and they're using a patch cord with a channel adapter. And if I look at a report and it says they used a channel
Right.
adapter,
Red flag.
it's
Red flag.
like,
My day
er,
my day job, I work for a manufacturer, and once upon a time I used to look at test results for warranty. And if I saw where they were using permanent link test, and then there was like 5 or 6 channels,
yeah.
that automatically spurred a phone call from me automatically,
Yeah,
because I know what you
because the link
did.
they were too long.
Yeah, they were too long. You
The
couldn't get
link,
them to pass. you know.
yep.
But that's a whole different. Yeah,
And
break out that digital scope. I want to show people. I want to show people why pass through connectors. You said you had the USB microscope.
oh
Yeah,
yeah,
yeah, break that.
let's grab that.
Let's show that, because like I said,
So
I'm kind of like you. I'm on the fence. I try to understand where people come from, and I understand, that while terminating the traditional RJ45 may not be the easiest, there are some skills that you got to build to do that. But so people prefer the pass through because it's easier. But just because it's easier doesn't mean it's the best, right? You know, just because that's the way your dad used to do cabling doesn't mean that's the way you should do cabling. So, you
Exactly.
know, that's why, yeah. So let's, because I really like this. You know,
So we're going
this
to
won't
start
solve
out.
this issue, but at least it'll give people, hey, look, on that video, Mike Pennacchi showed here's what happens when you don't have the right tools.
So this is a USB microscope I got on Amazon. It was like $30. I think the stand cost more than the microscope.
You're gonna have to
But
send me the links to that. I got to get me one of them.
I tell people, if you have kids, grandkids, or you just like to see stuff up close, this thing is pretty nifty. And what I like is, let's come in here. Let's get the right thing. If I come up to camera. All right. So one of the things I want to start with is I've got this connector right here, and I went to connect it on there, and I used the wrong crimp tool. And I just want to show you what that looks like. This is where I've used the wrong crimp tool to try and crimp it. And you were talking about, you know, the right tools. And it just destroyed this jack. And we can see that the pins in the center are pushed down further than the ones on the outside edge. And it's just not going to work. So using the wrong tool to crimp those down, absolutely no good. Now, the other one is the pass-through Ethernet connector. So here I've got a chunk of Cat6 cable that's terminated with a pass-through connector. Now let's see if we can get this cranked up far enough here so we can get a good look at this. And I just want to note that I did run this through and do a test with this using the patch cord adapters. This is about a 1/2 meter patch cord. And if we zoom in, we can see there are the end of those conductors sticking out right there. Now let's see if we can get a good view of this from the side. We'll wind this all the way down. And notice how those are protruding out just a little bit. And so it's key that we use the right tool for terminating this. I use the tool recommended by the manufacturer. We see that for the most part, nothing's sticking out, but that one pin right there, pin number 8, is sticking out just a little bit. So when we go in and terminate those pass-through connectors, it is critical that we use the correct tools for doing that. And even using the correct tools, sometimes we don't get the results we're looking for. Now, here's the other end of that patch cord. And I use the same tool for doing it, and we see that we get that same result, that pin number 8 is poking out just a little bit. So for all the other pins, looks pretty good, but pin 8 sticking out just a little bit. So there's just a close-up look using the magnifying or the little microscope there, that USB microscope, at a connector that we use the wrong crimp tool on right there, and on one of those pass-through connectors.
Now, the other thing you said you could show me too is when you're talking about those cameras at the restaurant where the insulation was stripped back. There was something you were going to show me with that too. I can't remember what it was though.
Flip over here. So let's take a look at this right here. So this is an example of a cable that I use in class. And this is a very, very short MPTL link, right?
Right.
We've got an RJ45 jack on one end, and we've got one of our little ice cube connectors on the other. So one of the things that we see a big mistake people make sometimes, and I saw this at the pizza restaurant, was they strip the insulation back, and this is an exaggeration, but they don't get that insulation all the way up into that connector so we have the strain relief.
Right.
Now, one of the things that's really important is when we're testing a link like this, that we use a patch cord adapter that matches the category of the cable, and we do the MPTL test. And why that's so important is that if I use a channel adapter on this, this will pass. And so the channel adapter does not include the crosstalk and return loss for that connector right there. So when
use your fingers. Hey, Mike, use your fingers, because I know the answer to this, but I want it to be seen visually. Put your finger where the test starts with a channel adapter.
With a channel adapter, the test
Thank you.
starts back.
Exactly. Now put your finger where the test starts with a patch cord adapter. Bingo.
Right
There
there.
it is right there. The thing that's most likely messed up, the mod in that you've crimped on, if you're using a channel adapter, you're not even measuring that loss. You're not even measuring.
No. And in fact, this one no longer passes. And the reason it no longer even passes the channel test is because we don't have any strain relief. Those poor little teeth in that crimp-on connector right there, those things are unable to hold that cable in place because that's not their job. And in fact, let me grab a cable back here, because one of the things I love about my job is I get to spend a lot of time just making cables to show things, right? And so one of the ones that we're seeing more and more is direct attached.
Yep.
And where people are running a cable from one RJ45 plug to another.
Mm-hmm.
And to be truly direct attached, we have to use the field terminated connectors. So the standard requires that we have field terminated connectors. These provide much better connectivity, much better crosstalk performance. These happen to be shielded ones. But when we're doing that, we need to do that. And we need to do the direct attach test, which uses patch cord adapters, which starts the test right there. So it's one of those things where you can't just pick and choose the rules you're going to follow.
No,
if
you
we're
can't.
going to do it,
you can't.
But
what else would we have to argue about in the industry if we didn't have those? Right?
Well, and I'll tell you, I got really good feedback from the wireless group because, they're always looking at, there was a guy from Dartmouth College that gave a great presentation on using hybrid fiber. They were running access points out to some light poles around a big grassy area, and it was well beyond what you could get out there with, it was beyond the 100-meter limit. And so they ran hybrid fiber, and then they had a media converter out there at the end.
Mm-hmm.
And there were some good presentations, but we gotta look at both sides of that access point.
Yes.
And making sure that all of that is working properly. And it's all balancing, like those field terminated connectors are sometimes too big to fit into whatever housing we're using. In fact, when I was doing this presentation, one of the questions that came up was somebody said, I always tell people to use Cat 6A. I said, it really depends.
Right.
What's the application? And so I called one of my buddies at a cabling company and I said, Don, you're always talking, you're doing all these blogs and everything. What do you think? And he said, look, we sell Cat 5E, 6A. And he said, you can pull 100 watts to 100 meters on all of them.
Yep.
So they'll all support PoE. We've got our limits. We can get 2.5 G base T out to 100 meters on Cat 5e. We can get 5G out to 100 meters on 6. We can do 55 meters at 10 gig on 6, and we can do 100 meters. So when it comes to 5E and 6, if I don't need 5G base T, then what I'm looking at is how flexible do I need it to be?
Right. And
because there are some applications where 6 with the spline in the middle is just too unruly.
Right. And you like I said, this argument appears everywhere. I mentioned it earlier when we talked about fiber. People says, oh, fiber. Fiber has its place, but it's not the answer to every single question, right? It's the same thing with category rated cabling. You said, people are like, well, I'm going to put in Cat 6A. Okay, why are you putting in 6A? Do you have the applications that need to run that? Or is it going to be like the type of run, like you mentioned, where they ran it and they poured concrete over top of it, right? Okay, You're not replacing that cable. So, if they want to put in 5E because they got a camera out there that's only pulling 100 meg, 5E will do that all day long, twice on Sundays, no problem. But if you're worried about the future, because they might be putting in pan tilt zoom and maybe 4K stuff, and okay, then maybe go to a higher grade cable, but don't just automatically go to the higher grade cable unless you absolutely have to.
Absolutely. And it's choosing the right thing for the application. Now, here's one that was kind of, so we talk about when we're doing training on certification, we talk about the nominal velocity of propagation, that we need to know it, we can measure it. And then with fiber, we look at the index of refraction. And so what I did was the index of refraction is we take the speed of light and divide it by the speed of light in the fiber. And the NVP, we take the percentage of the speed of light at which well, if you do that math, you'll find that multimode fiber is a little bit slower than Cat6 cable. And
I've never done the math on that. I've never done the math.
I got into a discussion with somebody one time. They said, I said, hey, let's just run, Cat6. And they said, well, we want to do fiber. I said, well, why? Well, it's faster. I said, you're doing 1 gig.
Right.
It's gig is a gig. They said, well, it gets there fast.
Well, that's getting into the weeds there, buddy. That's getting into the weeds.
And it is, but it's so much of this is breaking down some of those things.
Right.
And I find that, one of the biggest challenges is going against the first thing somebody's heard.
Yes.
That if they've heard that and you're telling them something that's contrary to it,
right,
you're pushing a big rock up a hill.
Exactly. And I get this question in my classes every once in a while because, people seem to think that the reason we can talk, from the East Coast to the West Coast or from America to Dubai is because of fiber. No, we were doing that before fiber was invented. Okay. People don't understand that. But, the real reason I would pick multimode over, Cat6 cables, not because of the speed of the signal, is because of the bandwidth capabilities comparison between those two. So
absolutely. And when we start getting into wave division multiplexing and everything, what fiber can do. And that's one that I think was really interesting. How you get into the hole of watching YouTube videos and then 12 hours later. In fact, I got an Oculus Quest 3, and maybe in one of the sessions, I set it up so I can inspect fiber. I can see a window floating out there, and I can see the fiber inspection camera. So with the pass-through on the Oculus, I can drive the test equipment, I can get into a web browser, but I can still see the world around me. So it's great for watching YouTube. I was surprised at how few fibers there are in those the fibers that run across the ocean.
Oh, yeah.
There's really not that many fibers, but there's a massive number of wavelengths that run across each one.
Yep. Mike, absolute pleasure having you on, my friend. We need to get you back on and again this year to talk about the classes, the flu classes and stuff like that. Because
we won the Cabling Installation and Maintenance Magazine Innovation Award for the training program this year. So that was pretty exciting.
Nice. So I hope we didn't go too in the weeds for you. So the answer is not as simple as, does it pass and will it work? There's a lot more stuff going on. Sometimes it'll work, even though it may not pass the certification test. So I was hoping to solve some arguments in this one, but guess what? We're not going to do that. It's not going to happen. There's always going to be that opportunity. The key is, again, use quality products, quality installation, quality tools. And then that way, 99 and 100% of the time, it's going to help you. Until next time, knowledge is power.
That's it for this episode of today's podcast. We hope you were able to learn something. Make sure to subscribe so you don't miss out on future content. Also, leave a rating so we can help even more people learn about telecommunications. Until next time, be safe.